There's a high, very dangerous environment there. Now, the missions of our satellites are mostly communications related. About 66% of them relate to communications. And it's quite interesting, when you look at how many military satellites there are only 6% of the satellites in space are believed to be military. The rest, 96%, are civilian. And that's quite an interesting statistic as well. Most of them are used for navigation, earth science, meteorology, remote sensing, and other things like that.
No, can I interrupt you
Yeah.
there? How do you know that they are civilian? They may be described as civilian, but I think you have an assumption that they are civilian because all of them are dual use. And so you cannot get away just by saying 96% are good and only 4% are bad.
That's one of the grave problems with any regime for space is how do you verify? Much of the rules and regulations that we have, not much of them, but almost all of them, are voluntary, and they're not verified. It's very, very difficult to verify or to confirm declarations made by states. Sometimes that can be done scientifically, but it's a grave problem that has persistently hindered the development of international law in space, the difficulty of verification. Now, what about sheer numbers? Since the launching of Sputnik in 1957, there have been no less than 5,000 launches of satellites into orbit. And of these, about 850 are still active. There's 850 still active satellites that are flying around. They're owned by 44 countries, and there are 7 countries on Earth that currently launch satellites. And this number is almost certainly to grow, and that in addition to the European Space Agency. One satellite costs about $250 million. $250 million is about the typical price of a communications satellite. So they're pretty expensive assets up there. And states are going to want to not have them experience trouble and go out of business, whether because of space debris or by willful attacks. Now, whenever there's a test of a weapon in space, and there have been several, most of these are called ASAT, or anti-satellite weapons. In 2007, for example, China destroyed one of its own satellites in space, and as an ASAT test, and they successfully destroyed it. The problem is that their destruction left 1,700 fragments of this satellite that are 4 inches more or more in diameter, adding to the further problem. And there are another 40,000 fragments that are less than 1 centimeter, at very high altitude, by the way, so they're going to be around there for a long, long time, for decades. Now, the world community has tried to adapt very, very slowly and incrementally through treaties. When Sputnik went up in 1957, I'd like to remind you, by the way, that the rocket that put Sputnik into space was also the world's first ICBM. It was designed to carry a 3-megaton nuclear warhead. And this was the rocket that put Sputnik in space, and it very, very clearly shows you the dual-use nature of this space rocket technology. You can put a warhead on top of it, or you can put a satellite on top of it. It is what classically is known as dual use. That rocket, by the way, is called the R-7 rocket. And the Sputnik satellite, by the way, weighed only about 80 kilograms, or about 180 pounds, roughly. In 1959, the UN established a committee on the peaceful uses of outer space to promote science and civilian uses and access to space. In 1963, the world took a step forward by outlawing explosions of nuclear weapons in space. That was the Partial Test Ban Treaty, negotiated in the last months of the John Kennedy administration. But the real landmark treaty was the Outer Space Treaty in 1967, which prohibited the orbiting, I emphasize, orbiting, of weapons of mass destruction of any sort, in particular nuclear weapons. And what was also interesting about the Outer Space Treaty is it said that the fundamental laws of international law and the UN Charter apply also to space. So all of the provisions in the Charter about avoiding threats or use of force are equally applicable in space. And that's a very important feature of that treaty. Also, the
I interrupt you
Yeah,
again. You haven't been able to enforce the UN Charter on ground. And how do you think you can enforce it in outer space when you can't even do it at home?
Yeah. Well, this is a continual problem you have with the rule of law. What do you do when the rule of law is violated? All right, all of you, you're 6 universities, you come to school, someone runs a red light. Okay, what do? Do you get rid of the law on having red lights because it's not always observed? Law is a evolving, living organism. It adapts to its changing circumstances. It's a work in progress. It seeks to achieve certain things in society, even though it's not fully complied with. It's what society wants to. Think of it as a goal more than a fact, and that, I think, is what we're seeing now in the realm of outer space law. We see a lot of troubling activities going on, but we still hold on to the idea that there should be a normative framework guiding state behavior in space, and that it's a worthwhile goal to pursue, even if it can't be enforced or even verified under our current means. It doesn't mean it can't grow in that direction. Now, later on, after 1967, the U.S. and Russia, Soviet Union, concluded a treaty called the ABM Treaty, which prohibited the placement of weapons in outer space that can be used to shoot down missiles. And it also outlawed all the related technology, the special radars and things like that could be used to support a strategic missile defense. That was the ABM Treaty. Unfortunately, the ABM Treaty has ceased to exist. The U.S. pulled out of it in the early years of 2000 or so, and so that constraint no longer exists. There are a whole bunch of other treaties that have concluded that I'm not going to get into right now, establishing, for example, liability for who's responsible if a piece of satellite falls down on Earth and lands on your head. All right, who's responsible for that? Well, the world has tried to work this out, and or if it strikes a civilian aircraft, for example, who's responsible? It's called the Liability Convention. There's a registration convention which North Korea just recently signed, which requires states or calls upon states voluntarily to register their satellites. And we have a UN Office of Outer Space Affairs that acts as a database for these different satellite launches. But again, it's totally voluntary, and as Ambassador Kamal says, if a state says that a satellite is purely civilian, the UN has to take its word for it. We have no way of verifying or confirming that. Also, many of the space launch institutions around the world, like NASA and the one in Germany and elsewhere around the world, they have this consortium called the Interagency Space Debris Coordinating Committee that meets and tries to establish guidelines to limit and regulate the amount of space debris in the atmosphere, in outer space. But that, however, is strictly voluntary, and it's not at all rooted in strong international law. So we have right now a number of threats to this whole legal regime. We've got states that are testing and developing anti-satellite weapons of all types. These are the way these work. There's many ways to shoot down a satellite. You can hit it with another satellite going at high speed. That's called a kinetic kill vehicle, where the impact, what you're doing is destroying it just by impact. There's no explosive involved. You just simply ram into it. That's a kinetic kill vehicle. You have a laser or particle beam. You have electromagnetic radiations that can destroy the surface or blind satellites. You have explosives that can be used that send out shrapnel. You have all kinds of different such techniques like that of knocking out a satellite. It's really very easy. Your lasers can be put in space and shot, or they can be shot from the ground. These are all kind of concepts. But I want to emphasize one thing strongly right now. There are, as far as we know, no weapons that are deployed in space. We're looking here at tests of weapons, at experiments, at developments that are underway, but there are, as yet, as far as we know, no deployed space weapons. There are enormous, however, risks of this happening because of all these R&D efforts that are going on. And there are